Good morning, guys. So we are on week 4, but we're going to go over our homework from last week. Um, just real quick to go over what we did and make sure that you guys did your homework. So I want you guys to email me what you got. So you're supposed to do the functions and all the stuff for the minerals that I put down for you. Go ahead and email those to me so that I have them. And you can just send it to the email that's on the syllabus on the Facebook page. If you don't have it, your parents do, so go ahead and ask them. So real quick, just to go over, what are water-soluble vitamins? And water-soluble just means they're dissolved in water, so they just get flushed through your system. And which ones are they? So which ones are the water-soluble vitamins? Makes it real easy because there are only 2 types. Your B vitamins and vitamin C. Fat-soluble, dissolved in fat. Those will stay in your body a little bit longer because they also get stored in fat. Those are going to be the rest of your vitamins. So everything that's not a B vitamin or vitamin C. So A, D, E, and K. Now, for the minerals that we looked at, let's look at chloride first. Chloride is the rest of what salt is. So sodium chloride is salt. So it's an electrolyte. Helps balance out your fluids. Make sure that most of the time you'll know that you're low on chloride if you're dehydrated. And that'll just be something that you're low in electrolytes in general. If you're dehydrated, you're low in water and or low in electrolytes. Copper. You need copper to help. Copper is normally red. A lot of the minerals that are red are going to be the ones that help form the red blood cells. So copper helps form red blood cells. It'll help with your bones and nerves and immune system too. And it helps you absorb iron, which is also good for your red blood cells. Phosphorus helps you build bones. You need phosphorus to help add strength to your bones. Very, very, very important for that one. And also your teeth. You also use it to metabolize carbs and fat, so you need it to form energy, and you also use it to make protein. So phosphorus is very important. And your last one, manganese, is... So that one's an interesting one, and you'll normally see it on things that have been fortified because it helps you with everything. It helps you build pretty much every part of your body. So it helps you build bones, helps your blood clot, helps you with hormones, metabolize fat and carbs, help you to absorb calcium, and it also helps you regulate your blood sugar. So there are a couple ones that help with blood sugar regulation. Manganese is one of them. You also need it for your nerves. It helps your nerves to fire correctly. Very important one. So just make sure you send those to me. Send me what you had for the last week. We didn't go over everything today, just to make sure you didn't. You're not just copying down what I said. So just send me those. And then I want to go over your food journal real quick. So what have you noticed about your food journal? How has it changed over the last 4 weeks? Have you made any changes to your food choices since you started looking at your food journal and looking at your foods? How's your sleep been? So now that you've been able to track it and look at it consistently, how have you been sleeping? And are you still eating mindfully? I know a lot of you started for the first week. Are you still doing it? And if you are eating mindfully, have you seen any changes? So I want you to send those to me too. You can also just put these on the Facebook page. Either way, I'm not picky. Just let me know it's you. Now, this week, we're going to talk about calories and exercise. And I know this one's going to be Seth's favorite because there's going to be a lot of information on how to use your food to help you during exercise. Now, use this one. With this one, we're looking at both athletes who are working out all the time and normal human beings. So we're going to look at everybody in between and see how you burn your calories, how you take in your calories, and how you use them. First, what's a calorie? We talked about this last week, but week before last. Ball of calories, the energy to raise the temperature 1 kilogram of water, 1 degree Celsius. I know you guys are looking at me thinking, that's not the definition you gave us last time. A calorie for food is different than an actual calorie that's used for measurement. in chemistry. So a calorie used for food is actually a kilocalorie. Instead of raising the temperature of 1 gram of water, it's 1 kilogram of water. So that's the difference between a calorie, which is the little tiny unit of measurement they will usually use in chemistry, and a kilocalorie, which is used to measure the energy in food. Because if you measure the energy in food in regular calories, it's going to be a rough day because there's going to be a whole lot of calories in there. A kilocalorie is just 1,000 calories. Now, where do you get calories? If you all don't all have this answer correct, I'm going to be a little upset. Because you get your calories from macronutrients, your protein, fats, and carbs. Now, just as a reminder, do you remember how many calories are in each gram of your macronutrients? Protein has 4 calories a gram. Carbs have 4 calories a gram. Fat has 9 calories a gram. And alcohol has 7. Now, how do you burn your calories? Now, this is a little bit of a trick question because you're burning calories all the time. Most people are going to say exercise. It's not necessarily just exercise. You burn calories from breathing, from your heart beating, from you being a little fidgety with your hands or your feet. You burn calories from literally everything you do because your body is always working. So a little bit of a trick question because you are always burning calories. Oh, if I had done my PowerPoint correctly, I would have known I already went to ask those questions. All right, so how do you measure the calories you burn? The way most people do, actually, I take that back. The way people would have done it 10 years ago is just math. You measure or you calculate your TDEE, which is your total daily energy expenditure. And you do that there, for that you get, it's kind of an interesting calculation because all you do is get your resting metabolic rate or basal metabolic rate, which is what you are burning just by sitting here and doing nothing. It's basically what you're doing while you're sleeping. So if you were to do absolutely nothing all day long, the calories you burn were your resting or basal metabolic rate. So you take that and your total daily energy expenditure, the only way you measure that is there's a little chart that gives you something to multiply your resting or basal metabolic rate by. And normally it's like 1.7 or it goes by your activity level. And that's what they've decided is your total daily energy expenditure. So is that going to be super, super accurate all the time? Not really. But if you look at the calculations or the equation below the RMR or BMR, that's a pretty intense calculation. And that one tends to be pretty close. Not always, not for everybody. And I want to point out that this is for people over the age of 20. So it's also not going to be right for you. Kids are very, very hard to calculate. So anybody under the age of 20 is extremely hard to calculate their resting or basal metabolic rate because there's a huge range for you guys. So you can calculate yours, and I'm actually going to give you a second to go ahead and try to calculate it to see what it gives you. And to get your weight in kilograms, you multiply by 2.2. To get your height in centimeter, you take your height in inches and multiply by 2.54. In case all of you did not remember your weight in kilograms or height in centimeters. All right, did you get it? I hope so, because I'm finishing up mine. Okay. So just to give you an idea, oh, got my age incorrect. All right, just to give you an idea of what you might get. And again, this is only close if you're over 25. It's also going to change on a regular basis based on what you ate yesterday, or it just gives you a really basic idea. Mine is 1,429 calories. And that is if I did absolutely nothing all day. I'm going to burn 1,429 calories. So when you do your total daily energy expenditure, the idea is to multiply that by the amount of exercise you do in a day. So when you do that, you also have to add in, this makes it very difficult, the non-exercise activity thermogenesis. And that is what it, you produce heat anytime you do anything. So this is what you're doing, or the heat you're producing when you're not exercising. But it is also not the heat you produce when you eat. It's the heat that you produce when you breathe or when your muscles are moving, but you are not necessarily exercising. I know it's in the name, but I want to make sure you know this is non-exercise activity thermogenesis, the heat that you produce when you are not exercising. TEF is a thermic effect of food. So different foods have different effect on the heat that you produce. And heat, if you are producing heat, you are expending energy. And the thermic effect of food is going to be different for certain foods. Some foods are harder to break down, so they're going to produce more heat, and you're going to be using more energy than others. So that's going to make a big difference in your total energy expenditure. The NEAT, so the non-energy activity thermogenesis, which has a big effect on how much muscle you have, because your muscles are going to burn more calories at rest than fat is. And the thermic effect of food. So if you're eating, for example, if you're eating crunchier foods, they're going to be harder for your body to break down. And that's going to have a bigger effect on your total daily energy expenditure. So it's very difficult to actually measure the calories that you're burned from this. And we have new things. I'm going to skip down to the activity monitors. Those are going to be more like the Fitbits or the Polar watches or things like that. Those are going to be what's attached to your wrist, and they're measuring how many calories you're burning by your heart rate. So you put in your height, your weight, your age, and it measures you, and it gets a kind of a guess of how many calories you're burning based on your heart rate and all those other factors. Now, metabolic testing is going to be the most accurate. So that's what's testing the air that's coming out of you. It's also testing your heat. So that's going to see, they basically put you through a stress test. They put you on a treadmill and they hook you up to all kinds of wires, and they strap your face into one of those really fantastic, it looks like a breathing treatment device. It's actually horrible. So I don't fully recommend it, but that'll be they use those for metabolic testing to get a much more accurate measurement of the calories that you burn in that time. And that can give them an idea of how many calories you would burn on a regular basis. Again, all of these are just an idea, and there are so many factors that go into the calories that you burn that it makes it a little bit difficult to measure the calories. So if you're looking at things like on MyFitnessPal or on a calorie counter, those calories are not necessarily going to be accurate for you, but we're going to talk about that in a minute. So how do you measure the calories you took in? So we talked about measuring the calories that you put out and that you used. How do you measure the calories that you take into your food? How do they get what they got on the food labels? So for you, it's just going to be math. You're going to be adding up all the calories that are in foods. And since you really have no idea, you're going to take the calorie counters from websites or nutrition labels or things like that. Now, the way they got it on the food labels, what they used to do is they would put food in a container and that is completely surrounded by water, and set that food on fire. And after it is completely burned, they measured the rise in temperature in the water. Like we talked about, a calorie is just the rise in temperature in water, getting a kilogram of water up 1 degree Celsius. So they measured the temperature of the water, and they saw how much the water increased, and that's called a bomb calorimeter. That's how they used to measure for food labels. It's a little bit different now. They don't have to do that anymore. Now they just do math. They see how much protein, fat, or carbs are in the food, and they just do the math. So they know how many calories are in a gram of carbs, how many calories are in a gram of protein, how many calories are in a gram of fat, and they just calculate it. They're very boring now. They don't have to actually set the food on fire anymore. But it'd be nice if they did, because that's actually a little bit more accurate. Because it's not always 4 grams of 4 calories per grams of protein, 4 calories per grams of carb, and 9 calories per gram of fat. But it's close. So if you look at a food label, it's going to be almost exactly what it says. There's going to be a little bit of discrepancy based on how much fiber there is or if there are sugar alcohols in it. So there's a little bit of a different calculation. But basically, they just do the math on it, and that's how they get the calories. Now, this one's for you guys, so make sure you're, let me make sure that you're not muted. I'm going to unmute you, Nadia. I'm going to mute you. Maybe, if it lets me. There we go. What happens when you eat more than you exercise?
You gain weight? I don't know.
Yeah, that's it. You gain weight. Now, my next question, maybe if it'll let me click on it. What happens when you exercise more than you eat? What's the opposite of what you just said?
You lose weight.
Yeah. Is it actually that easy? Is that math as easy as it sounds?
No.
No, not even close. It's in theory, and a lot of people think that it really is that easy. So in theory, a pound of fat is supposed to be 3,500 calories. If you burn 3,500 calories, you should burn a pound of fat, right?
Yeah.
Not exactly. So when you're looking at that, you're going to be getting rid of water weight. You're going to be getting rid of a little bit of muscle. You don't necessarily know how many calories you're burning, and you don't know how many calories you're taking in. So it's not quite as easy as it looks. So we'll go over why real quick. First, are you in an area that you can do some exercise?
Somewhat, yeah.
Okay, we'll make it work. So I'm going to show you how many calories or how much exercise it would be to burn a couple of calories. So the first one, we're cheating. It's water. Water is 0 calories. You can't do anything. No moving, no blinking, don't do anything. So nothing for a couple seconds. So I'm going to let you freeze. All right. Did you actually burn 0 calories?
Yeah.
Not exactly.
Well, that's it.
Were you breathing?
I guess so.
Yeah, I would hope so.
Yeah.
If you are breathing or doing anything, you don't actually burn 0 calories, but you're close. Now this is 1/8 of a little tiny apple. So you're going to burn off 11 calories. So I'm going to have you do 60 jumping jacks first, and then I'll count 60 seconds for you. So go ahead, 60 jumping jacks, ma'am.
Done.
All right, now jog in place for 60 seconds. All right, I'll count. I'll do the 60 seconds for you. You ready? Go. You didn't know you were going to get a workout before swim practice, did you?
Yeah, I know.
Almost there. Five more seconds. All right, you're good. That was a lot of work for a little apple, wasn't it?
Yeah.
And that was 11 calories. So if you think about how many calories I burnt in a day, so doing absolutely nothing, I burned about 1,400 calories in a day. That was only 11. Exercise really doesn't burn a whole lot of calories. So let's go through the rest of them. The rest of them you don't have to do. If you'd like to, they're there, but we'll go through the rest of them. So if you look at a small cube of potato, just like a tiny 1 inch by 1 inch cube, that's about 9 calories. So you're going to do 30 high knees and 20 wood choppers. So raising your arms over your head and chopping down pieces of wood. 30 high knees and 20 wood choppers to burn 9 calories.
I can easily burn that at the gym.
Oh, very easily. Now, a quarter tablespoon of peanut butter, and that's like, a quarter teaspoon. A teaspoon is right about your thumbnail.
Mm-hmm.
A quarter of that is 20 calories. So you have to dance for 60 seconds, run in place for 60 seconds, jump 50 times, and then scrub the floor 50 times. That's a lot for some peanut butter.
Yes.
Now, 2 lettuce leaves are only 10 calories. So if you jump rope 100 times, do 10 lunges, and catch 10 fish, that's 10 calories. And a tablespoon of oats, a tablespoon is right about your thumb. That's 9 calories too. So if you're jogging in place for 60 seconds, you do 20 squats and 10 crunches, that's 9 calories. So if you're looking at all these, relatively, you're looking at exercise not being a whole lot of calories burned. But skipping over to my next page, there are so many factors that influence the calories that you burn. So let's say if we go back, the exercise that you just did you actually burn 11 calories?
Probably.
Probably not.
Probably not. I know.
Because those are the numbers I based were on an adult. So you're going to be different because the types of exercise you do, food choices, the hormones that you have, which is going to be different than a 30-year-old, and just you in general are all influence the calories you burn. So all of these numbers are going to be different for you than they are for me. So I'm going to have to do different exercises than you are to burn the same number of calories.
Mm-hmm.
So for the types of exercise, do you know what aerobic exercise is? I give you a hint, you're going to do it today.
I don't swim.
Yeah. So aerobic exercise is anything that your body needs oxygen for. So swimming, anything longer distance, running, anaerobic are things that your body uses or doesn't use oxygen for to get everything to your muscles. Does that make sense? Aerobic just means oxygen. Anaerobic means no oxygen. Anaerobic is going to be things that are really short term, like running quickly for a very short period of time, or lifting weights, things like that. Aerobic is going to be more like swimming, or if Seth and Marie were here, parkour, anything along that line that you're going to be noticing that you're breathing really heavily afterwards.
That's me every time I go to the gym.
Then you are doing aerobic activity. Congratulations. Now, I got a question for you. Does aerobic or anaerobic activity burn more calories?
Aerobic, maybe?
Yeah. Now, do you know why?
You're doing it for longer?
Yeah, it's the breathing part of it, really. Since you're breathing heavily, it's a lot more work for your body. You normally burn about double the calories during aerobic exercise than you do during anaerobic exercises. But They're a little bit different. So you burn more calories afterwards doing anaerobic exercise than you do during aerobic, because there's more after. It's called afterburn. You're continuing to burn more calories after you do anaerobic exercise than you are aerobic. So if you go to the gym and lift weights, then you're going to be burning more calories afterwards than you were if you went to swim class. Make sense?
Yeah.
Now, food choices also influence your how many calories you burn. So what's the difference between, let's say, a celery and apple versus fruit juice?
Fruit juice probably has more sugar.
That's true.
It has more chemicals. I don't know.
See, I love this question because you went way further into it than you had to. One's crunchy, one's not.
Wow.
So one just has more fiber. So if you are chewing your celeries and apples, are you going to produce more heat in your body?
Mm-hmm.
Yeah. And are you going to burn more calories chewing?
Yeah.
Yeah. And your body's going to take longer to process it just because it's crunchy. It's got more fiber. Fruit juice just goes straight through you. It's real easy to process. It just goes in and out.
Yeah.
Gets processed very, very easily. Now, the next one. So remember how easy that was. If you are having green tea and black coffee versus soda, what's the difference in your calories?
I don't know because I don't drink tea and coffee, so I don't know.
Well, good. That makes your life easy. So green tea, all of those have caffeine in them. Soda has a bunch of sugar. So if you're not having a whole bunch of cream and sugar in your coffee, green tea and coffee are going to help you burn more calories because you don't have the same number don't have the same number of calories as you do in soda. So caffeine helps you burn more because it heats you up, makes you move faster, makes your blood move faster, gets it where it needs to go. Does caffeine get you excited?
Mm-hmm.
Yeah. So that's going to help you burn more.
I don't even drink soda very much.
Don't tell me that. Did you write it down in your food journal?
I haven't drank it in probably like a month.
That's awesome. Well, good. Now, I got another one for you. It's pretty much the same question as the first one. So white flour and sugar versus quinoa. What's the difference?
What's quinoa?
Quinoa is kind of that grain. It's kind of like rice.
Oh, I know what it is.
Yeah. So the biggest difference is white flour and sugar have most of the fiber taken out of it. So they're very, very easy to digest, really easy for your body to pass through. Quinoa is harder, so it's going to put more work on your body.
Yeah.
Now, omega-3 and omega-6 fatty acids, I'm just going to tell you because this one's a little bit harder.
Yeah, I don't know that.
This one requires a little more thought. Omega-3 decreases the inflammation in your body, while omega-6s increase the inflammation in your body. So you got to balance them out. They're both very, very important, but they have to be balanced. Omega-3s are normally in like fatty fish. Omega-6s are more in oils. So as long as they're balanced, you're good. Now, omega-3s burn more calories because they're decreasing the inflammation, so they're doing a little more work. Omega-6s bog you down a little bit more with inflammation. So they're not necessarily making your body work harder, but they're bogging it down. So you'll burn more with omega-3s. So if you're eating a good fatty fish like salmon, than you would with omega-6s. Let's say most omega-6s come with carbs, so this one's a little difficult. There's both in butter. So we'll work on that. There are both omega-3s and omega-6s in butter. There's actually a really good balance in that. Now, this next question is a little bit different. So if you're hungry or you're full, are you going to burn more calories?
Hungry? I don't know.
Yeah.
Yeah, hungry will make your body work.
Kind of. So when you're hungry, you're going to try to preserve all of your energy. So you're not going to want to use as much energy. So when you're full, you're actually going to burn more calories, sometimes, depending on the food you eat. So if you're full and you go for a run, your body's going to say, most of the time, okay, I'm good. I can go ahead and use these calories. If you're hungry, your body's going to try to hold them back. so that you're not using quite as much. That's part of the reason why you get tired when you're hungry. It's because your body just doesn't want to use the calories for energy. It's going to try to save you because it doesn't know how long you're going to be hungry. Now, that's the same thing with over and under eating. So if you're overeating, your body is actually going to use more calories on a regular basis. If you're under eating, your body is really going to hold you back because it doesn't want to use the calories because it doesn't want you to be starving. But the downside is you are very rarely going to use more calories or as many calories as you're overeating if you are overeating. So there's going to be no balance there. There's a good middle place in there that you're burning the right number of calories to keep you energized and make everything work correctly, but you're not having too little or you're not having so much that you're gaining weight.
Yeah.
Everything's a good balance. Now, there's another big one, and we're not going to go too far into this because in total honesty, this is a little bit above middle school, high school level, but I'm going to tell you anyway. Because there are some hormones that influence the number of calories you burn. Do you know what insulin is?
I want to say that's sugar.
Kind of. So insulin actually helps you use your sugar. So when you get sugar in your bloodstream, your insulin helps you keep it at a normal level. When you have diabetes, it has a really hard time doing that. Either you don't have enough or it's not working correctly. So your blood sugar is just getting too high and staying high because the insulin's just not working the way it's supposed to. So insulin is also a storage hormone. So it's going to keep you from burning the calories. It's going to put them away in your fat cells and in your muscles. So that's going to affect it just because it's storing things, you're not going to burn them. Thyroid hormones are a little bit different too. There are certain thyroid hormones that don't let you burn as many calories if they're not working correctly. Leptin is one that's important because leptin makes you full. That is that feeling that all of a sudden like, oh yeah, I don't need to eat anymore. I'm good. Leptin just went into your brain. And cortisol is your stress hormone. That actually makes you hungry. If you're stressed long term. Short term, it's going to make you not hungry. Long term, it makes you crave sweets to try to keep you boosted. So those will more influence your calorie burn because they affect what you eat. So if you're feeling full and satisfied because you have leptin or enough leptin in your body and in your brain, then you're not going to eat as much. If you have a lot of cortisol in your body for a long term, you're going to eat more sugar. So that's how they affect the calories that you burn, because they more affect what you eat.
Mm-hmm.
Now, you are the biggest influence on your calorie burn. So your gender, your age, your body structure, how you perceive food, and your genetics are going to be huge in influencing your calorie burn. So almost always, are boys or girls going to burn more calories?
Girls? I don't know.
Actually, it's boys. And there's really one reason for that. Do boys have more muscle regularly?
Yeah.
Yeah, most of the time they have more muscle. So that's it. Muscle just burns more calories than anything else in your body other than your brain. So because they have more muscle, then they're normally going to burn more calories. Now, your age also makes a difference because at certain ages you burn more than others. You tend to burn more when you're growing, obviously, because your body's using them, than you would if you're an adult and just sitting. So your resting metabolic rate is actually going to be faster than mine. So you're going to burn more calories doing absolutely nothing just because you're growing. And body structure makes a big difference too. But if you have more muscle, then you're going to burn more calories.
Yeah.
Your perception of food is an interesting one because the way you think about it actually burns more calories. So I'm going to use diet soda as an example, because if you drink a sugary drink that doesn't actually have any sugar in it, your body's going to think you had sugar. So it's going to try to burn the calories from that sugar, and it can actually give you low blood sugar because it tries to take care of the sugar that you didn't have. So the perception of food and what you're thinking about your food can actually make a big difference in the calories you burn and how your body responds to it. So that becomes very interesting because if they've done a couple of studies on people who drink diet sodas, because they tend to be heavier than people who don't, or people who drink regular sodas. And that made no sense. The difference is that they would have the diet soda, their body would think they were having sugar, so they would process it like they were having sugar, which would give them low blood sugar, and they would counteract it with some sugary food. So they were actually eating more sugar than they would if they had just had a regular soda. Now you can counteract that with having a good food with it, but that makes a big difference. So that's an example of your perception of food influencing the calories that you burn.
Mm-hmm.
And then your genetics. So if you will burn calories very similarly to your parents, partly because you eat what they eat for the most part, and partly because the genetics that they pass down are going to be similar. So you're gonna burn things the way they do. You're gonna see food similar to the way they do. You're gonna have a body structure similar to them. So your genetics also play a role in how you burn calories. Now, I have a couple of questions for you. Does everybody burn the same number of calories by doing the same thing?
No.
No. Why?
So they could do it longer or maybe shorter?
Yeah. Or let me see. Am I going to have the same hormones as you do?
No.
Am I going to have the same body type as you do?
No.
No. Am I going to eat the same foods as you do?
No.
No. So everybody's going to be a little bit different. Now, does everybody, if I eat, let's say we ate the same thing all day long, are we going to use the calories the same?
Yeah. What do you use the calories from the? Yes, I don't know.
Not quite, because
there's difference.
Yeah, because we're different. That's it. Now, for that, does that mean, let's say, so if we put all of our foods, let's say we use a calorie counter for our food journals. If we put all the same foods in, is it going to come out with the same thing for both of us?
No.
Yeah.
Oh, yeah.
Yeah, because we put in the same foods. Does that mean it's super accurate for both of us?
No.
Nah. So they're definitely ones to take with a grain of salt. They're not going to be the same for both of us. They're just guidelines. And that's very important to remember because some people take those calorie counters like MyFitnessPal as law, and they think that they're always right all the time. They're not, and that's okay. They're just guidelines. They're just to give you an idea. Now we're going to talk about exercise. So, and what foods work best for different kinds of exercise. Now, for generally, if you're eating well and having a healthy meal an hour or two before your exercise and getting protein within 45 minutes after to rebuild your muscles, then you should be good. Now, for heavy exercise, like when you go to your swim team practice, having a protein or carbohydrate drink during your training, and you might need more food during and after. Just because your muscles are going to need to be built up, you're going to be doing more, you're going to be burning more, and you're going to need to rebuild the muscles that you broke down during that time. And you're going to need to replenish all of your carbohydrate stores so that you can do it again the next day. Now, if you're trying to gain weight and strength, and this is going to be more for a hefty weight gain and strength, like bodybuilders, you're going to need more protein and more carbohydrates, because you're getting rid of all of your stores. And if you don't have any more, you just need to replenish them. And higher protein also will help you rebuild those muscles. Now, if you're trying to lose fat and gain strength, you're going to need lower carbohydrates because you're not trying to replenish those stores. You're trying to use up the fat instead of putting the carbohydrates back in for you to use. You're going to take those away so that you use the fat in your body instead. And do you remember what amino acids are from a couple of weeks ago?
No, not really.
They're just the pieces of protein.
Yeah. Okay.
So if you're getting the pieces of protein, there's not a whole lot for your body to break down. So it'll just go straight to your muscle and help rebuild where it needs to. So for your goals, and since we were talking about macronutrients a couple of weeks ago, what foods do you need to go do your best?
Protein? I don't know.
Yeah.
Protein?
Yeah. And what foods are protein?
Like meats.
Mm-hmm.
Egg.
Yeah.
Egg. There's one more. I remember. I want to say avocado, but that doesn't sound right.
Avocados are more fat, but you're close.
I don't know. I can't think.
That's a good one too. There's some beans, and everything has protein, so it's kind of a trick question. Everything has protein. Meats and eggs. Beans are going to have a little bit more.
Mm-hmm.
All right. Now, I'm going to go back a little bit to answer this question, because this will be your homework question. How is energy intake and expenditure measured? Going back a little bit. So we missed this one. So this is the energy expenditure, so the calories that you burn. And most of the time we'll do it with, a lot of times right now we'll do it with activity monitors like MyFitness or Fitbits and Polar watches and things like that. But you can also math it out. It's not going to be super, super accurate, but you can try it and it'll give you an idea. And metabolic testing is also going to be a good way to do it. It's actually going to be the most accurate way to do it, but it's the most expensive and the least fun because they hook you up to a lot of things. So this will be how you measure the calories that you burn. And for you to measure the calories that you take in, you just do math. You just add them all up.
Mm-hmm.
Going back. So that'll be your homework question. I want you to think about that a little bit more and do, I'll put this presentation up. So I want you to do the calculation that was on the other page so that you can get your resting metabolic rate. Now that one is for somebody who is 20 and older, but it at least gives you an idea.
Yeah.
And then I want you to check your calories during a workout. So you can either check it online and see, so you can measure how long you were at your swim team lesson or how long you were at the gym, or you can wear an activity monitor if you have one. I don't care, as long as you do it. And then think about the foods that will work best with the type of exercise you do. So if you were going to make your healthy meal to go before or after exercise, what you would put in it.
So just pretty much check like how many calories I did like on each machine at the gym pretty much?
Yeah, you can do that.
Okay.
That'll work. Do you have any questions?
No.
All right. So you'll be able to watch the rest of this. I'll go ahead and post it as soon as it downloads, and then you are good. And then we had a couple of the micronutrients at the beginning. I know you were at camp. We had a couple of micronutrients that we talked about that I want you to, let me go all the way back. That I want you to tell me the functions of. Those are the 4. They're on the last presentation too. So just email those to me, okay?
Okay. Yeah, right. I was trying to watch it, but we had to get accepted for the Facebook group or whatever.
Oh, you should be on it. I will do that now, and then you guys will be good.
Okay, thank you.
Yeah, and I will see you next week. Have a good swim team practice.
Yeah. Oh, I won't be here for the next 2 weeks.
Okay, then I will go ahead and send it to you guys.
All right, thank you.
You're welcome. And if you guys don't get added to the Facebook page, let me know today because I'll do it right now.
Okay.
All right, cool. I will see you later.
See you later.
Bye.
Bye.